I might want to put down there here, this is beavers, or this is stumps, I guess. And this is beetles, beetle colonies. Sounds like the batteries fell over that. Okay. Next condition is about spread. So to check my condition of spread, I need to look at my residuals. So in order to look at the residuals, I had best do a linear regression. So let me hit stat, calc, doing number 8. And, oh, so I got a R of 0.916, so R squared 0.839. Yeah, that's pretty strongly linear. Let's check the residuals. So I'll go, now I can go and graph the residuals. So I'm going to make a scatter plot of the residuals against my input list. And my Y list will be the residual list. Plot those, and those look fairly evenly spread, equally spread. Little more spread out over here than over here, but not bad. I mean, there's not a clear spray pattern. So I'm going to say I'm okay to go. Okay. We'll just say a little spray. Fourth is normality. So I'm going to do a box plot of the residuals. So I'll go in my stat plots and I'll hit box plot, or you can hit histogram, whichever you want to do. Tell it to do the residuals. Going a little fast, I know. Okay, then I'll do a zoom 9. Oops, what happened there? Zoom 9. Oh, that didn't look bad. A little skew there. Not a heavy skew. We'll just say not heavily skewed. Spot, shorter tail over here. We'll say a little skew. Okay. We'll say we have met conditions and move on. Okay. So for my significance test, formula for, oh, that looks terrible. Formula for my significance test, I need a test statistic. And that test statistic is the slope over the standard error of the slope. Thank you, ma'am. Okay. How am I going to get that test statistic? Everybody has this test on your calculator. All right, so let's run the significance test. So I go stat. You ready? You with me? Go over to tests and go to the Lin-Reg t-test. E. Or F. Yeah, if you've got the interval, then it's F, right? They put the interval before the test?
No, the GOF.
Oh, goodness it fit. That's right. You've got a lot more than I do. Okay, here we go. X list. List 1. I put mine on list 1 and list 2. Frequency, leave that alone. So you can put values in a, or kind of, values in one list, and say in the next list, the frequency list, say I have 3 of that value, 2 of that value, 10 of that value. Okay, so that's, so if you can name a list for that. Okay, your test says that you're both testing for slope or correlation. We're testing for positive slope. Now, this regression equation, you don't have to put it in. It's going to use the regression equation for list 1 and list 2. So you're going to go down and you're going to calculate. So t is 10.5. My p-value, it said, is essentially 0. 4 times 10 to the negative 10. My degrees of freedom, it said, was 21. And then it nicely gives me, in case I haven't run a regression and written it down, it gives me the y-intercept, the slope. Oh, it gives me the standard error of the regression line. It gives me r squared for that sample. It gives me r for that sample. I think that's all it gives me. Okay, so it gives me some information if I need it for later. Yeah, well, but I'm surprised the new calculators don't do it. Okay, so now I make my interpretation. Since p equals 0 is less than any reasonable alpha, we reject our null hypothesis. We have evidence that the slope of the least squares regression line for beetles given, or I guess number of beetles given number of stumps of beaver stumps, is positive. Ta-doom. If we were testing for correlation, we would have gotten a positive correlation. If we were testing for correlation at all, we would have gotten that there is an association, that there is a correlation, all from that little test.